All right, I'm going to let Tamara start. Tamara is our president of
Okay.
Astronomy Club of Tulsa, and take it away, Miss Tamara.
Okay. I'm glad to have all y'all. My name is Tamara Green. I am the president of the Astronomy Club of Tulsa. I'd like to welcome everybody to our Zoom meeting for January 19th, 2021. Next slide, please. Welcome, new members and guests. We're delighted to have you join us. Our members have many wonderful opportunities to share observing the beautiful night sky and make new friends and lasting memories. There's also opportunities for public outreach to get others interested in our hobby. So whenever you're out and about with us, please feel free to ask questions, offer suggestions, or even volunteer to help out at our events when we're able to have them again. Hopefully that will be soon. Any new ideas are welcome, and we're glad you're here. Okay, next slide. All right, upcoming club events. Due to the increased numbers of COVID cases, we will be holding our members only observing nights only on Saturdays until the beginning of daylight saving time. We will not be holding public events until the pandemic subsides. And hopefully, with this vaccine, that will happen soon. I'm really hoping that we will be able to have events again sometime this year. But for right now, we're still just doing members only events. Our members nights are going to be Saturday, February 6th and Saturday, February 13th at the observatory at 5:30. I will try to make it to these. I haven't been coming out because it's been too cold for me. I've just now getting over some post-COVID complications myself, and because of that, my body does not handle cold very well, nor does it handle heat very well. So I will try to be out if it's not too cold. Our next Zoom meeting will be on Tuesday, February 16th at 7 p.m. And our March members nights will be Saturday, March 6th and Saturday, March 13th at the observatory starting at 6 p.m. And our next Zoom meeting will be Tuesday, March 23rd via Zoom, and it will be at 7 p.m.
All right.
Now, our observing nights guidelines, we want everybody to set their equipment at least six feet apart. Family groups should remain in their observing area. Children should stay with a family member, an adult who brought them at all times. We encourage the wearing of masks, especially when around other people. We discourage sharing equipment unless given permission by the owner. The restroom will be open. Please exercise your hand washing and sanitizing. The classroom will be open for short warming up periods. And when you're in the building, please wear your masks. Masks must be worn at all times in the building. I know there are some people who like to gripe and say, oh, what about my rights? Well, it's everybody's right to stay healthy and have their family members stay healthy. So please wear your masks. Nobody's trying to control anybody. The only thing that people are trying to control is a spread of this stupid pandemic. So the dome and other areas of the building will be closed, and observing these guidelines will help us continue to enjoy our hobby while keeping ourselves and other people safe. So next, please. Now,
Okay.
Dan Smith is going to give a presentation on thanks, Brad. Everyone has the right to stay home if they don't want to wear a mask. Thank you, Brad. I agree. Daniel is going to give us a presentation on stacking multiple exposures. So take it away, Daniel.
All right, I got to stop screen sharing. And Daniel, your turn.
Hello, everybody. My name is Daniel Smith. I'm the vice president of the club. I do quite a bit of astrophotography. Some of you might have been here last month. I kind of showed some basics of taking pictures with a DSLR.
Daniel?
Yes.
Might tell people if they want to see your presentation better to use what we call speaker view up in the top right corner.
Okay. Yeah.
Choices. So you're fine, but they may not all know that.
Okay.
All right.
but I do imaging. I do astrophotography. I started probably about a year and a half ago. I was just doing basic DSLR stuff, and then now I'm imaging with a equatorial mount. I've got a couple different telescopes I use and cool astronomy cameras and things. But today I'm just going to show you, because a lot of people don't know, they've heard about stacking astro photos, but they're not sure what that is or how you get started. And you also might have heard of something called calibration frames. And so tonight I'm just going to do a very basic overview of what that is using a program called Deep Sky Stacker. Now, Deep Sky Stacker is a free program. You can just Google search it and you can download it. It's free to use. It's one of the most basic stacking programs for astrophotography that you can get, and it's fairly simple. So I'm going to go ahead and start sharing my screen here. All right. So this right here is what's an astronomical object called M78. It's a dark nebula. Now, what this is it is a single frame, just one picture. It's a 2-minute exposure taken with my Celestron 9.25-inch SCT and a Hyperstar adapter. So I know it's kind of hard for you to see because, you know, Zoom screens are they're not the greatest. But anyways, you can see there's a little bit of detail there. You can see the nebula, kind of, sort of. I don't know if it helps if I zoom in, but you can see there's quite a bit of noise, different bits of noise there. But that's a single frame. So we're going to jump on over to Deep Sky Stacker. Now, ideally, you want to take multiple exposures. You want to take, you know, as many exposures as you can for stacking them. So for now, what I'm going to show you here on this screen, I've got 10 of these frames. So that's 2 minutes a piece. That basically would mean 20 minutes of total exposure time. So when you get this app or when you get this software, you open it up and you're going to hit at the top left. I know it's hard to see, but at the top left, it says open picture files, and you're just going to open your files in the program. If you're using a DSLR, it'll probably be raw files. If you're using an AstroCam, it'll probably be what's called FITS files. But you just open your light frames, and then it will load them all up, and you're going to want to check all of those frames. There's an option over here that says check all, okay? And then what you're going to do is stack them. Now, what I'm going to do for now, I'm not going to use my calibration frames, but if you go here, you're going to go to register, and then you're just going to hit, if you use your recommended settings, that's fine. That's the thing, you can change all kinds of stuff, but if you just go with the recommended settings, most of the time it turns out pretty good. Yes.
All we're seeing is the one picture. Are you showing settings and stuff?
Hang on 1 second here. Let me switch this. Let me switch it over here. And this one. Here we go. Sorry about that. All right, now you can see Deep Sky Stacker here. So you're just going to go to your open picture files and open your light frames. And then you want to make sure that you've checked all of them. And there's an option right over here that says check all on the left. Then you're going to go to register check pictures. And you can go with these options here. I mean, if you just go with basically what it says, you don't even have to change a lot of the settings. You can go with this button here that says recommended settings, and it'll tell you what you should use for stacking. And then you just hit OK, and it will register. Basically, what it does is it takes all your photos and aligns all the stars. I'm going to stop that. And then you can go over to stack check pictures. and you hit OK. And for 10 photos, like I'm using right now, it really, I mean, if you've got a moderately decent computer, it really doesn't take too long. So it's stacking 10 photos.
Daniel, speak a little slower because we're getting some feedback.
Okay.
I don't know why, but thank you.
Okay. So I've stacked 10 photos of the nebula M78. This is just an initial look at it, and I did not use calibration frames, and I'm going to explain that here in a second. Okay, so I'm going to jump on over back to Pixensight site here. Remember, this was the single frame. All right, now here's 10 frames stacked. And I don't know if your resolution is good enough, but it definitely shows a noticeable difference. What I'll do is I'll come to this area here. So here's 10 frames stacked, and there's one frame. So you can see the brightness, you can see more nebulosity, and a lot of that noise has disappeared as well. Okay, now that's without calibration frames. What are calibration frames? Calibration frames consist of things called flat frames, dark frames, and some you can use what's called either dark flats or bias, but those two are basically the same. What flats do is they help make the illumination. If you can tell in the corners of this photo, it's kind of dark in the corners here, and a little bit brighter in the center, because that's my optical system. That's what happens. So a flat frame will help even out that illumination. And then when you're using the dark frames and also the bias frames, that helps cancel out some of those things such as artifacts and noise. It makes the noise a lot smoother. Because that's something when you're editing a photo, is it's really hard to get a nice clean looking photo if you're having to deal with a bunch of noise. All right. So when you go in, when you're in Deep Sky Stacker, you're going to do the same thing like you did with open picture files, except you're going to open on the left, on the upper left, there's dark files, flat files, and dark flat files. So the way that you take these calibration frames, a dark file, a dark frame is basically, you're going to put the lens cap on your camera so that it takes zero light, and you want that to be the same ISO or gain of your camera, and you want to try to be around the same temperature. So, you know, if you're, it's good sometimes to take them out at night, but you want it to be the same, all the same settings as your light. Flat files are taken where you use an illuminated, some sort of illumination. Some people like to use the morning sky, and they just put a white t-shirt over their optics. And so what that does is it just gets an even flat field illumination when you take the pictures. I use what's called a LED tracing screen that I bought on Amazon for about 30 bucks. And it's just it's just pure white light. And I point my telescope at that. And you want your flat frames to be just long enough where your histogram is somewhere from a third to the middle showing on there. And then your dark flat files, similar to the other two, but with dark flats, what you're going to do is you're going to take and put your lens cap back on your camera, and you want the dark flat files to actually be the same exposure length as the flat files. Now, I understand that's a lot of information, but I'm just giving you the quick basics of what those are. And now I'm going to show you why those are important. I'm going to go back over to Pixensight here. So we already looked at the first frame, one single frame, okay? Then we looked at 10 stacked frames. Now I've got 95 frames that I've stacked. And at 120 seconds for each frame, that's about 3 hours of total exposure time. All right. So there's 3 hours of exposure time. And if I zoom in on this, there's hardly any noise at all. Okay. So we've eliminated a ton of that noise, but I still didn't use calibration frames. And you can still see the center of the picture is pretty bright and the corners are still really dark. Now let me show you, when you add those flat frames, those dark frames, and those flat darks, this is the picture that you get. Now, there's a lot of processing that still needs to be done. However, you can clearly see it got rid of the illumination in the corners, and you can see the nebulosity really standing out now. And you can see all the details in it just from adding those calibration frames. They make a huge difference when you're stacking photos. Now, just to show you what can be done, that's just the initial part, is stacking frames. Then you have to process, which you would use. A lot of people would use Photoshop for that. Some people use PixInsight. I use both. But when you go through all that processing after that, this is the photo that you can get. So stacking is the way to take your astrophotography game up to the next level. Because when you consider that that's a single frame and that this is 95 frames stacked with calibration frames and processed, it just shows you, what's possible. Now, processing is one of those things where it takes time to learn and it takes practice. And it's going to take a little bit of research, asking questions from other astrophotographers. But, little after little, once you get the hang of it, your pictures will start to improve and you can make some really awesome photos. So that's all I've got. I don't know if anybody had any questions or anything.
Well, thank you, Daniel. We're going to move on so we get to all our segments. So let you unshare, or are you already? Let me try to share my screen again. And we'll go back to our PowerPoint if I can find it. And we just did Daniel. And, well, Daniel's in the way. Sorry. One of our newest members, Eric Kingery, is going to share with us some of the books that he's been using. Eric is new to the hobby, like a lot of you are, and so he's been perusing the various bookstores and found out some great books that he likes. So, Eric, I'll get off here and let you do the share screen.
Okay,
or I
John,
guess he's going to do it live, so just click on speaker view.
Do I need to do anything, or am I okay?
You're on.
Okay. Hi, my name's Eric Carey, and as Daniel just said, to do what he was doing there, that takes a lot of study and work. But obviously, the more you put into something, the more you're going to get out of it. And you can see the dramatic differences. I mean, the pictures he took were just, to me, stunning. And I'm not going to tell you that I understood 80% of what he said, but I can also tell you that for those of you who are interested in astrophotography and have the time and the money and the patience to do it, is phenomenal. But I want to take you all the way back to the beginning. John has told me that there's a lot of people like me joining the club who would really like to learn more about astronomy and just maybe don't, they know there's a sky, they know it's dark, they know there's stars, but what else? I myself started my astronomy when I was a teenager. I started learning the constellations when I was approximately 13, 12 years old. Got my first 3-inch Edwin scientific telescope. Last time I used that thing, I was in high school. And then there was a hiatus of about 65 years. And now at the end of my time, I'm coming back to astronomy. So I consider myself an advanced beginner. So that's kind of where I am at. But when I started to really re-engage with this stuff was last summer. And I started searching out, because I have books, but some of my books go back, 65 years. So okay, a lot's changed. And I thought, I got to go back and update everything. So my brother sent me an old book that he found at a Goodwill. It was falling apart. It was called Night Watch. And I'm going to move this over so you can see the books, I think, I hope. Can you see that? Okay, this is Night Watch. And I started looking at this thing and I was just stunned by the presentation. Of all of the astronomy books I have seen, for someone who doesn't really know that much at all, this is a step-by-step, cannot fail guide. It's written by Terence Dickinson. It's been through several editions. Terence Dickinson founded the Amateur Astronomy Club in Canada, and this book has been through several editions. But I want to share with you some of the contents. If you're absolutely at the very beginning, this I would recommend highly over anything I've seen. And some of you guys with more experience could probably tell me more. But what I'd like to share with you is, the first thing is it goes through the 11 steps of the universe. And it's kind of a progression thing that goes on and on. It is phenomenal. And I've always been just floored by the beauty and the wonder of the heavens, whether just looking up in a night sky at Glacier National Park, or through a telescope that maybe John's had. It's just an amazing experience. If you want to get a sense of the vastness of the cosmos, this is a phenomenal job with illustrations and paintings. It takes you off to say, okay, so where do you begin? I have a story to tell you. When I was first learning the constellations, I think I was 12 years old, I had a little star finder, and that star finder's right here. And I was looking for the Big Dipper. Well, I thought I found the Big Dipper in the sky. I looked and looked and looked, and it was right overhead. And I finally found this little thing that looked like a dipper. And I got so excited about it. And then maybe several weeks later, someone said, well, dummy, that's not the Big Dipper. That's the Seven Sisters. It's over here. So if you've ever been in that situation, okay, that's me, all right? But it starts off and it shows you the Big Dipper, okay? And from there, and how to find it, and from there, it gets into the constellations. It has star charts, and using the Big Dipper, it actually points to all the other constellations. So first of all, you find all the bright stars, and that leads you to the bright constellations. And it takes you, and you can test yourself. Here it is with the lines. Of course, when you look at the sky, there are no lines. You say, well, okay, here's the Charioteer. Here are the twins. Here's Orion. Question is right over there. So you can actually teach yourself and then take this thing out and use it under the stars. Then it has a whole thing on stargazing equipment, binoculars, telescopes, lenses, all that gibberish about focal length and magnitude and power and all that, magnification power, that kind of thing. It explains all that here. It's at a top level, but you get a tremendous sense of what's going on. And the next thing it goes through is deep sky objects. Once you've learned the constellations, it'll show you where these things are. Now you'll say, well, my telescope's got a go-to on it. Why would I need all this stuff? Why do I need to know any of this stuff? I've been in scouting for 35 years. And one thing I've learned is in the backcountry, always carry a map. Yes, you have a GPS, but you always have to have a backup system. It also allows you to find things that maybe are not on your go-to telescope. So I still would encourage people, at least in my view, to learn the constellations. It's kind of a roadmap to the universe. So anyway, it goes through here. There's a bit on planets and how to observe them. There is a bit on astrophotography at the very beginning. And then I just feel like this is a great book. I took the time to go through this in detail because this is kind of a introduction to the next one I want to share. And I'm just going to give you a quick overview of the next one. The next one is by actually two authors. One of them is the same guy, Terence Dickinson. But this is called The Backyard Astronomer's Guide. Now, this goes into much more detail than the first one. It's in three different parts. The first part is equipment, binoculars, and telescopes. The second is observing the night sky and how you would go about the planning part of it. And then this would, what Daniel was saying, it goes a little bit into astrophotography. So if you're interested and you think, someday I want to do that, this is a great place to start. So these two books, to me, are probably the best books that I could recommend for people. This is more in depth. This is for someone to say, okay, I know the constellations, or I really would like to get into astronomy now, and I'll learn this other stuff as I go. This is going to give you an awful lot of good information. I have the third edition, The Backyard Astronomers. Actually, this is the second. There is a third edition out. It has a picture of the Horsehead Nebula on the front of it, but you can get these, and they're well worth the price. Those are the two. Now I'm going to very quickly, if I still have a little bit of time, I want to, I'd like to show you a couple things that I think are really good as far as planning an observation. Of course, you have the wonderful things you get in Astronomy Magazine and Sky and Telescope every month. So that's a planning tool. Another book is called Turn Left at Orion. It's by an Italian guy and Dan M. Davis. And what this book does is it tells you what to observe, when to observe it, and how, both with binoculars and telescope. Now, if you guys, some of you may be waiting for a telescope. In the pandemic, you may have to wait a while. If you have a pair of binoculars, you can start right now, because there's things up there that you actually see better through binoculars than you can through a telescope. So this book will handle both. And what it does, I'll just show you an illustration, is it'll say, okay, in the constellation of the Big Dog, there is an open cluster called M41. And what it does is it shows you kind of where this is. Here's a picture of the Orion and the Big Dog, but then it'll actually show you what that nebula looks through a finder scope, and then a drawing of what it looks like through a small telescope. So you actually get to see what you're looking for. And there's stuff here that tells you about this stuff. It's a great, great way of maybe say, I want to take control of this thing, because all I get on my go-to thing is like M41, M42, M43. If you'd like to find out a little more about what you're trying to see, this will provide that. It's kind of a guide. It doesn't give you everything, but it gives you the brighter things for small telescopes and for binoculars. So that's Turn Left at Orion. The next thing is published by Sky and Telescope. For those of you, and I'm kind of getting into this, binocular highlights. This does basically, it actually specifically tells you about 109 objects you can see with just binoculars, preferably with a tripod. But it's organized by date, and there's color diagrams of where these things are. And it is a lot easier to use than, say, if you never used a telescope before, if you have a pair of binoculars, it's a great way to start getting used to the sky. And you actually can use both. When we had the comet that came last fall, we first spotted it and got the full thing through binoculars. So again, I like this one, the binocular highlights. And then there's a couple others. I don't know if you've heard of the person or a lady by the name of Sue French. She wrote Sky and Telescope magazine for years and years, and was acclaimed by her write-ups of the different nebulae and galaxies and stuff. She wrote a book called Deep Sky Wonders, which I got, and Sky and Telescope has actually put those things together and published them in a book. And it's a beautiful book. And she does she'll tell you what these nebulae really are, what the galaxies are, something about them, the science behind it, as well as where to find them. It's a tremendous planning resource. This is for people who really want to get beyond, say, just the big stuff, the Pleiades, the Hyades, and all the rest of it, okay? Very quickly, and since John put this on the website, I'm going to just tell you about these. Sky and Telescope also publishes an atlas, pocket atlas. Not necessary for everything, but if you get into deep sky objects, by that I mean the nebulae and the galaxies and things like that, this is actually kind of like a roadmap. It'll help you find the things, because sometimes it can be a little tricky, but it has star charts of all these things. And of course, if you already know the constellations, it helps. Okay, the Charioteer is right over here. So right over my roof, it has all the stars there. So you start looking through here and you can actually, this can help you. In the old days, before we had GoTo, we had to use like a major bright star and then, slew over here until we found the thing. This is what we would use. And I still like these things. I'm old fashioned, but I like these things. The last thing I want to share with you, I don't know if any of you have ever done this or not, but I will tell you that I enjoy reading articles in Sky and Telescope, but some of the terminology they use, I'm not all sure about, okay? Well, I found this book. One more, John, I'm done. It's called Astronomy, a Self-Teaching Guide. Is in its 8th edition by Diana Moke. And this is used as a companion text to a lot of astronomy courses around the country. But it goes through and it defines all of the terms you're going to run into in like Astronomy magazine, Sky and Telescope. It helps you understand what you're talking or what they're talking about and gives you a greater appreciation. So, astronomy is a lifelong hobby. And I think the thing that we all share with this thing is the deep wonder and the beauty of it all. It's just, to me, phenomenal. And one thing I have learned is the more you know, the more wondrous it becomes. I'm done, John.
You did an excellent job, and I'm going to put all this in the newsletter for February. So you can catch our newsletter and see the resources. The Pocket Atlas comes in 2 sizes.
Yeah.
Eric has the enhanced high definition.
This is for the big pockets.
And it comes in a smaller one, like a 5x7. And I have both of them, but it's an excellent situation. All right. Well, I'm going to just skip on over to Brian Kyle so that I don't go back to the PowerPoint, because Brian is going to show us some of the meteorites that he has in his own collection. And he's the planetarium director at the Tulsa Air and Space Museum. And they have some collections out there. Is that right, Brian?
Yeah, that's right. I got a picture of a few of our samples there, and then I've got as many of mine as I thought appropriate. So go through a few of those and some of the explanations of what is a meteorite, where do they come from, what do they want, and all that kind of stuff. So
well, we're a little deep into the program, so let's try to do about 10 minutes and then get to our main program.
All right, I will start screen sharing here, I think. Eeny, meeny, miny. Yay!
Comment to everybody. All your comments are popping up in the middle of the lecture, so let's stop the comments.
All right.
FYI, those don't show up on the recordings. It's just where you put the message to pop up.
Well, it shows up in the middle of my screen.
Somewhere on here. Oops. Somewhere on here
You can
is.
turn it off, Don.
I know, but I'm just making a comment.
There it is.
Down at the bottom there, Daniel.
All right. So can everybody see that?
Yes.
All right. So this is basically just an overview of meteorites, what they look like, what different types are, things of that nature. So let's start with the basics, which are the three key types of meteorites. Now, the ones that a lot of us see in museums are the iron ones. Those are basically just a giant chunk of metal that fell out of the sky. And the way these guys form is kind of cool because you would think that if a meteorite formed in space, you would assume that it would just be a mixture of different stuff floating around out there. But the iron ones are different. They can only have formed from the cores of ancient planetesimals and dwarf planets and even major planets that smashed themselves to pieces in the earliest days of our solar system, because only in the largest, most massive planetary objects do we see differentiation where the heavy metals sink out of the molten suspension of all the rock and sink down into the core. That's why our planet has an iron core, because all the iron sank when the Earth was molten. So that's where these guys came from. Now, the stony ones, those are more from what would have been the crust of these ancient things. They're mostly silicate minerals, the kind of stuff we see on Earth. Most of us have a lot of silicate minerals in our front yards. They're generally pretty lightweight. They usually have 10% metal or less inside them. And then there's the really weird ones that are stony iron meteorites. They are a mix of a little bit of everything. Some of them may have come from the mantles of these early worlds. Some of them may have just formed out there in space when bits of rock stuck together. It really depends on their cohesion. Now, identifying them when you're out in the middle of nowhere in your friend's land and you happen to come across one of the easiest way of finding them is to bring a metal detector. Most of the time when we find meteorites, they're usually the iron ones, and they set off a metal detector like nothing else does. And they also are visually very distinct. Every meteorite has to, of course, come through the atmosphere at some point, and that causes a great deal of stress. Now, on the iron ones, we see a lot of melting, and they kind of look like this weird molten little lump of Play-Doh we'll see later on. And they'll often have little holes in them. These are what we call vesicles, where as these things are coming in, if they've got gases inside them, those gases boil off and burst their way through this slowly melting piece of iron, and we get that nice little hole. Now, the stony ones come in more or less intact, but they have a crust that builds up on the outside as the minerals on the outside fuse into what we call a fusion crust. And so they'll look like basically just pitch black rocks. And they are a lot harder to find. They don't generally set off a metal detector. So, and all the time that I have been studying meteorites, I have yet to see one outside of a university. So I do have a fragment about that big, but I don't actually have a whole one. And neither does the museum. They're a lot harder to get a hold of. Now, another kind of distinctive thing of finding a meteorite is iridium. If you go and do chemical analyses, that's actually one of the reasons why we know that an asteroid contributed to the extinction of the dinosaurs, because the layer in our bedrock that differentiates dinosaurs and no dinosaurs is filled with iridium. And we don't see a lot of that on Earth, but we see it everywhere out there in space, because that heavy stuff, like we were talking about with iron sinking to the Earth's core, all the really heavy, dense minerals or metals, and iridium is the second densest element on the periodic table. It sank down there pretty quick, and we never saw it again. Now, how do they get here? Meteorites, if you want to be really nitpicky about the term, a meteorite is the rock we find in the ground. In space, it's called a meteoroid, and that's just floating out there, minding its own business. Most of them hang out in the asteroid belt, but there are plenty of them whizzing around our solar system, usually at tens of miles per second. And every now and then, they crash into us. And that's pretty cool for us, because these guys usually date back to the earliest days of the solar system. So each one of them is like a little mineral time capsule into how things used to be. Now, when they hit our atmosphere, they get slowed down a lot by air friction. So by the time they reach towards lower atmosphere, they're usually moving at several times the speed of sound. Most of the time, they'll either burn up or they will soft land on the surface of the Earth, and usually this happens without incident. Nobody really notices. Other times, that happens. Now, that's a little bit more rare. That was the Chelyabinsk incident that happened back in 2013. I think a lot of us remember when that was on the news. So that is an evidence of what we call a bolide event. This is when one of these guys will come in and just explode due to the huge friction. Now, this guy was a stony meteorite, and they're a lot more brittle, so they're more prone to these violent explosions that we sometimes see. Now, these are a few of the meteorites we have at the museum. Just about everything in our collection there is iron-based. So we've got the ones on the left. These are mostly from China. So a lot of these guys would have been from the Natan province in China. A lot of times we find meteorites in groups. And this is often because of these explosive events. An asteroid will come in low, blow up at 30, 40,000 feet, and scatter its fragments all over the Earth in a very specific region. In fact, here in Oklahoma, we had this exact same thing happen in the 70s with the Lost City meteorite group. So this is kind of the most common way we find it. Usually you don't just find one, you usually find lots of them. The fragments can be anywhere from the size of a pebble, like the little one we have on that picture on the right. That's from the Campo del Cielo meteorite. Other times we will find them the size of a small smart car. So it depends on how lucky you are. And on the ones on the right, I don't know if you kind of got to squint to see those, but those are ones that show a lot of that melting I was talking about. They kind of look all lumpy and smooth. That's another visual characteristic that helps us to find them out in the field. Now, this little guy is one of mine from what we call the stony iron group. And we see inside them a lot of kind of randomness. All the little crystals inside are all jumbled around. They all look really weird. Now, we don't see that quite so much in stuff that has iron in it here on Earth. On Earth, all of our iron formed inside of a magnetic field, so the crystals usually go in one specific direction. And a lot of these objects that formed these meteorites, or these meteoroids, though, they oftentimes didn't last long enough to establish a magnetic field. So their crystals are much more jumbled. Now, this little guy is a little bit more distinct. Those pretty yellow things in there, those are olivine crystals. Olivine is a fundamental mineral here on Earth. We have this thing called Bowen's reaction series. Olivine is sort of the thing that gives birth to most of the minerals we know about that are silicates and ends up with quartz at the very end. So that one's kind of a prettier one. Then we've got this little tiny sliver of an ancient meteorite. Let me see if I always have to write down the name. This particular one is considered to be a fragment of one of the oldest on Earth. It was the Muonionalusta meteorite, which was found in Scandinavia. It is just a hair over 4.5 billion years old, so almost older than the Earth. And again, if you squint, you can kind of see some of those jumbled crystals in there. Now, these guys always have a really complicated crystal structure because of that lack of a magnetic field. Every time we cut one open, we see a different structure. And so a lot of the times you would think that when you get an iron meteorite, oh, that's it looks cool. But if you actually cut it open, it looks a lot cooler on the inside. So a lot of times you'll see these things sold like this, as slices. Now, they also contain other metals. They're not just iron. There's also a lot of nickel, as we discussed, iridium, and other just common metals found throughout the universe. Now, this little guy is a stony meteorite. This is my sample. This one's actually from the Chelyabinsk asteroid impact. And that one, you can actually see a little bit of that fusion crust on the right side. It's a lot darker than it is on the left. The left side is a little bit of the inside of the structure. So they kind of look a little bit more like Chex Mix on the inside. They'll have grains, all different minerals, all different colors, all sort of compacted in there together, kind of like what we see in a lot of rocks here on Earth. In fact, that's kind of one of the things that makes stony ones so hard to find, is that they look a lot like they're made of the crusts of ancient planets. And so when they land on the crust of our planet, it all kind of looks the same. A little bit trickier to find. Now, we don't always just find meteors from just deep space. Sometimes, very rarely, we can actually find them from other notable celestial bodies, specifically the Moon and Mars. And sometimes we can identify these based on matching them up with moon rocks brought back from the Apollo missions. Other times we can match them up based on chemistry that we see from orbiters studying the moon and Mars. So this little guy right here is about the size of my pinky fingernail here. That is a fragment of a lunar meteorite that has been chemically matched to the far side of the moon. thanks to the Lunar Reconnaissance Orbiter, which has mapped the chemistry of the entire lunar surface. Now these guys we've only really started identifying them since the early 1980s. So there aren't very many of these guys out there. NASA has quite a few of them, of course, but they do match remarkably well with the rock samples brought back by Apollo missions, and again, the chemical matching from orbit. Now our moon, as we all know, we've all seen it. We know it's got lots of craters, and every single one of those craters blasts debris out into space, and eventually some of it just finds its way here. So it was really only ever a matter of time before we found these guys. Now the Martian meteorites, they're a little bit more rare. The one I've got here is, well, about that big. I just call it a grain, but that little thing formed on Mars 2.1 billion years ago. Now Mars, being a close neighbor to the asteroid belt, does not have a positive relationship with the asteroid belt. It has some of the biggest craters in the solar system. And a few of them were big enough to blast material 30 million miles to us. Now, these are a lot more rare and, interestingly enough, almost always found in Antarctica. We all have some of us have heard of the meteorite called ALH 84001, which was found in 1984. And that was a big deal because when astronomers and geologists cracked it open, they found what they thought was fossilized bacteria. Now, whether or not it actually was, still nobody really has decided on that. A lot of people say it's just a blob of minerals. Personally, as a geologist, I think it's a little bit of bacteria, but that's a soapbox I won't stand on right now. So to date, we have no samples of Mars that have been brought back by spacecraft, unfortunately. So we are just really going by the chemistry of what our landers and rovers have shown us. And thankfully, they have shown us quite a great deal. We knew back with the Voyager probes, or not the Voyager probes, the Viking probes, what the geology we would be looking for in these rocks was. That's how we were able to identify this one back in 1984. And we're still identifying it today. And before you say anything, yes, I know that sample is not red. You'd expect it to be red coming from Mars, but not all the rocks on Mars are that color. But the fact that they come from Antarctica, I think, segues pretty well into the presentation that we're about to see. So that is all I have.
Very good. Just to comment, Brian, about the Lost City meteorite.
Mm-hmm.
I saw that one come down.
Oh, wow.
I don't remember whether it was Christmas or spring break. I was in my mom's backyard in McAllister. And it came out of the southwest and went all the way across the sky to the northeast.
Oh, man, I wish I could have
Then,
seen
of course,
that.
we read a few days later that it was found. And then on our 40th anniversary, we went to Washington, D.C., and I was walking through the Smithsonian Historical Museum, and there it was.
I might have seen it then. I was there through their meteor section, and I remember looking at all the different ones that might still be there.
It's about the size of a small football. It was the first one located by triangulation with sky cameras. But let's get to our program and see how I'm going to do this. Nope. So I'm not real adept at this. There's Brian's stony iron meteorite. The image brightened up a little bit. You can see little rocks in it. Our program tonight is from the Night Sky Network, which our club is a member of. And they have not quite monthly, but they have webinars several times a year, and you can log on to them, listen to them live. When they're done, they have them recorded, and we got permission to use some of those. So this is Dr. Cynthia Evans. She's a veteran Johnson Space Center scientist, and she's going to share her experiences searching for meteorites in Antarctica in the summertime, as she'll say in the program. That was a balmy minus 10 degrees. So she did two two South Polar summers there in December and January of 16 and 17, and again 19 and 20. So while we're doing this, I'm going to try to turn on the captions so you can kind of understand her a little bit more. But since it's pre-recorded, we won't be able to, make comments and ask questions of the narrator. And afterwards, I have a link where you can search it and look at it again if you'd like to. So I'm going to stop this, and I'm going to try to find the webinar.